Sir, let me start, sir.
Yes, Bhaskar, you can start.
Uh, Very good afternoon to everyone. Darkness cannot drive out the darkness. Only light can do that. I feel privileged to extend my warm welcome to our today sponsored FTP on Internet of Things in Smart City, Day 4 Session 2, organizing by Department of Electronics and Communication Engineering of Convolutional College of Engineering and Technology. Welcome you, sir.
Yeah, thank you.
When life puts you in a tough situation, don't think why me, think try me. The line is most suitable to our today's resource person, Dr. R Milton. Let me know about his biography. He received his BE degree in Electronics and Communication Engineering in 2005 and Master of Engineering in Embedded System Technologies at 2010 from Anna University, Chennai. He completed his doctoral degree from Information and Communication Engineering from Anna University, Chennai. He's having a 12 plus years of teaching experiences in various schools. He published more than 26 journal publications, 22 conference proceedings, and 2 books, 9 book chapters, and 4 patents in his credit. Presently, 9 research scholars are doing their PhD under his guidance. His area of interest, which includes a biomedical signal and image processing, medical imaging, retinal image analysis, computer vision, pattern recognition, machine learning, and deep learning. He is the reviewer of many reputed journals such as IEEE Transaction on Medical Imaging, Biomedical Signal Processing and Control, and etc. He received the Best Reviewer Award from the Elsevier Journal, Biomedical Scientist grant from a Department of Science and Technology, Government of India, for the project a national-wide study on a retinal detachment in India with emphasis on the risk of the fellow eye through fundus images deep learning in 2020. Youngsters or the pillars of India is perfectly matching to our resource person, Dr. R Milton. So without wasting, who is going to handle the session on the topic of application of IoT in a smart city, a research perspective. Please, sir.
Yeah, thank you, Bhaskar, for the nice introduction. Yeah, good afternoon, all of you, all the organizers, and of course the participants of the today lecture. So, Bhaskar has been highlighted. Basically, I'm a data scientist. I mean, working with artificial intelligence like machine learning and deep learning with biomedical data. But as far as this particular FTP concern, it is like smart city related applications. So the topic basically which is given to me is that I mean the applications of IoT in smart city, right? But today I'm going to deliver especially how the applications of IoT in terms of the smart cities can be clubbed with the deep learning algorithms. Because I was gone through the schedule of the whole, this FTP. So my previous speakers, they have been taught much more about this Internet of Things, and of course the smart cities. What are the architecture of smart cities, and all the fundamental and the theoretical framework you have been already learned from the previous speakers, right? So being a researcher, I was taught that how to deliver this particular topic quite interestingly, and especially I was came to know from the organizer of this FTP, many of the participants are like engineering teachers like me, maybe more are like maybe aged and experienced than me. and also I have been known many doctorates also attending this FTP. So while thinking this, a perspective in my mind, so delivering the applications of IoT in smart city in a normal way, you can feel like a classroom teaching, right? But being a researcher, how we can, differentiate from the normal conventional deliverable into different. So in that aspect, I'm going to deliver a lecture. So basically, I'm quite interesting to deliver the machine learning and deep learning algorithm to the students and of course the participants. But to match the scope of this particular FTP, so what I'm going to deliver, I'm going to use the deep learning algorithm for smart city applications. So in that way, I will be very confident to deliver like my own field of interest. And of course, this may be utilized for any smart city applications, right? So that's what my talk of the today. And being an NITian, I always like to teach more mathematics. So kindly bear with me. So I will be teaching more mathematics, not theory much more. So then only you can understand the whole concept from the scratch. So these are all my basic objective of the today talk. So let me share my screen. Yes, I hope my screen is visible to all of you.
Yes, sir, it's visible.
Yeah, thank you. So, as like without any further delay, you can see the topic which I'm going to present is applications of IoT in smart city. Basically, the whole presentations for the in terms of the research perspective. So before getting into the topic, so I want to share some more informations which is related to my institutions, so that the participants, they will get motivated, like where this institution is there, some kind of historical information the participants would like to know. So this is the institutions where I have been working, the National Institute of Technology, Silchar. So it is located in the northeastern state of our country in Assam. Basically, this institute is started in the year 1967 as a regional engineering college in Silchar. Then later, according to the NIT Act, so it was upgraded into NIT. And basically, this institution is offering many undergraduate and postgraduate, and of course, the doctoral program, in the branch of engineering, science, and management. And these institutions having lots of infrastructural facility for the betterment of students, faculty, and staffs. And of course, you may know that recently this institution is performing well in all the ranking framework, which includes NIRF and other global ranking frameworks. Currently, this institution is headed by the director, Professor Sivaji Bandyopadhyay. You can see here, this is the whole drone view of the NIT Silchar campus. You can find, the whole natural green beauty of, the Assam state. So, you can find lots of lakes inside the campus. So in between the lakes, the buildings were being constructed, and you can see this. And basically, this is the department which we have been working. So this department basically offering 3 degrees. Basically, it is offering the undergraduate degree of electronics and communication engineering, and also it is offering 2 postgraduate program in the department. One is communication and signal processing engineering, and another one is microelectronics and very large scale integrations. Then in the PhD level, this department is offering almost in all the specializations of electronics and communications and their related applications area. And of course, it is also providing the interdisciplinary area of research. Okay, so this is the like the whole historical information about the institutions where I have been working. Now, coming to the topic which is given to me is that like the applications of IoT in smart cities. Okay, so the whole architecture of a smart city, then how the IoT technology is helping in the smart city to make our human life in smarter, right? Now, coming to the application perspective, so whenever we required the smart life, of course, we always depends on the technology, right? So then only our life will make smarter. So in that aspects, if you look into the applications of smart city, like entire, the whole part and each and every step of the whole smart city life is applications, we can say. Like so in very specific, you can see the whole building. I mean, the structural health of the building is also one good applications of in the smart city. Then we'll move further into the other applications. So in our day-to-day activities, and of course in our day-to-day lifestyle, we have many applications in the smart city. Say for example, waste management. Okay, so you can see like in all these metropolitan and other municipality, so we have lots of bunch of waste management system, but it is not properly you know done by the corporations and other municipality people. So what happen if this this frequently happen in the smart city? So what happens is that, so it is not like a smart city. So of course we have to be manage this waste management with the help of the technology, right? So how the technology may be helpful, then how the technology can help to recover this waste in on time, then almost shifting and to clear the dustbins in on time. All these kind of applications, I think you might have heard about it. So this all, like we can say, the waste management. And of course, coming to the other very very important applications in the smart city is air quality. That is very very important. See, now if you're looking like in other big cities, like in a metro city, like Delhi, Mumbai, Chennai, in other big cities, and of course this air quality management is one of the toughest task in this. In the entire monsoon, winter time, Delhi is facing lots of problem in air pollutions. Okay, so if it is happen in the smart city, and of course it is not like a smart city, so like in our the whole applications, like what we are expecting and what we are experiencing in our day-to-day activity, that has to be automated. And of course those all these the day-to-day activity should be managed in a smart way, like in terms of noise monitoring, or in terms of traffic congestion, and of course in terms of energy consumption. So this is also one of the very important, because in our modern life we are habituating many electronic and electrical equipment in our home. Like, so if you use all the these equipments, then of course it's require a huge amount of power, right? So how we can manage the energy consumption? So that is also one of the very important applications in the smart city. And of course in the whole city it is customized, and of course it is wholly fully automated, and we can manage with some other applications like smart parking and smart lighting system. So automatically it can be switched on and switched off, and that kind of smart applications also we can handle, we can use in the smart city life. And of course, automation of public buildings, like if you have any public building, the whole building may be automated with the help of technology. Okay, so these are all like some of the sample applications of the smart city with the help of IoT. So here the backbone of all these applications, that entire it is working based on the internet. Okay, so without any doubt about this, like, so we have so many applications in the smart city. But being an engineer, if you deliver these applications in theoretically, I feel it's like a classroom teaching, right? I think you also feel the same, because if you type this waste management, in smart city, you will find a lot of material in the, in any type, in any basic search engines, right? And of course, in our being an engineering teacher, many of our students also doing lots of projects in this area, like in IoT and the smart city concept, like how the waste management, how the dustbins can be cleared, based on the SMS and GSM technology. So many like these projects nowadays students are doing. So all these you have been experienced in your experience also. If you consider the smart parking, the smart lighting, so lots of people are working in this area, and we can find lots of material in the internet. But in this particular lecture, I'm going to deliver especially one interesting application, which is called air quality management. I'm audible?
Yes, sir, you are audible.
Because I think some disturbance happened, I think so. Yeah. So, you can find lots of research paper in the Google Scholar itself, and of course, lots of product also available in the market. So, in that aspect, I'm concentrating on this air quality management. So now, looking into the applications perspective in the smart city, in the research, in terms of research, there are 5 top applications you can find. Okay, so which one, the traffic management and smart parking and smart waste management, smart infrastructure. So these all 4 are the common applications, we can say. The common applications you can find out of papers. But the very topmost priority management is air quality. So here in this particular talk, I'm going to be deliver how the air quality management has been managed in smart city with the help of the our artificial intelligence framework. I mean the deep learning framework. Okay, so now getting into the specific topic in the air quality management. So basically, the air quality management, it is one kind of prediction problem in terms of research. Okay, so now you can find in many places in Tamil Nadu, in any part of the country, you can see in especially in a petrol bank, or where the market, the huge people are gathering, you can find the like the quality, I mean the prediction screen you will able to find. So today, what is the temperature and what is the air quality today? And it is based on the, we can say, the AQI index. Okay, you can find these kind of common informations even in a small cities like Namakkal, and you can find Tiruchengodu in other related places also. You can able to find it, right? So the reason is that, so this is one kind of prediction problem. Okay, I mean, in the same way, how these predictions has been taken. I mean, those, they may be installed the sensor, and sensor automatically they will predict what is the temperature, what is the air quality, everything. Okay, but when this prediction is going to apply in smart city, we have to predict the future. Correct, that is very very important. Okay, in all these smart city applications. Okay, now in other case, in in most understandable manner, so I can explain you. You can see the Google rain harvesting system. Okay, so if you enable in the harvest, the prediction system in Google, maybe in your mobile or in your laptop or in your system, if this all this alert, you will get it. Okay, within today 9 p.m. you will get a rain. Okay, and most probably Google also predicting very well in all the countries almost, like developing countries like India. Okay, and if you go with some developed countries, and of course the whole country, how they have been in managed in the smart way, in the smart smart cities like US and other countries, if the predictions will be 100% perfect. Okay, we can see in many of the US places, you will get a notification from the speaker, in speaker, where you have been installed in every the public gathering places. You will get rain in 10 minutes. Okay, then exactly 10 minutes you will get the rain. Okay, so that kind of prediction, basically it is possible in all these kind of smart city applications. So in the same way, especially if you coming into the air quality predictions, or in the air quality management, this is one of the very very important research component, especially in our country, because the impact of air pollutions in our country. So most importantly, this is one of the important research component in the developing countries like India, and of course more polluted country other than India. Okay, so here in this context, what we can say that in general case, the government and all the city stakeholders, and they are trying to do the early precautions of the air quality management. Okay, to predict the future effect. Okay, so once if it is predicted, then we can ensure that, so like the sustainable development from the both stakeholder side as well as the government side. Okay, now how the predictions can be made. Okay, with the help of technology. So we need to like depend some technology, because we are going to predict early predictions, like for making more precautions. Okay, so in the same way, basically we need to depends on two technology. One is basically we need a data, right? So it is comes under the technology big data. Okay, so for example, if you want to predict the future data, we need the current data as well as the past data. Okay, so the whole like the informations that we have to be managed with the help of this technology big data analytics. And of course, once the data is available, we have to be predict the future. Okay, how it can be predict? So with the help of one of the important artificial intelligence technology, which is called deep learning. Okay, I will give you some kind of fundamental about all these technologies first, then I will getting into the how we can predict the air quality management in the smart cities. Okay, now coming to the basic understanding of these two technology. Okay, and of course this deep learning is playing a very important role in all type of predictions, and especially for the future prediction. The one of the very important deep learning algorithm basically utilized by all the researcher, which is called LSTM network. I think many of the researcher and many of the participants you might heard about it, like the LSTM network, which is called long short-term memory networks. Okay, so this is the the whole objective of this particular today talk. So I'm going to be deliver how we can predict the air quality management, I mean the future predictions, with the help of deep learning network, especially in the LSTM network. Okay, so all these whole concept I will be going to deliver in both theoretical way as well as in the tutorial format. Okay, so now coming into the audience perspective, and most of them are from the electrical background or maybe in electronics background. First we should understand about the technology. Okay, then we can clearly use these particular technology into the applications. So that is very important, so first we have to be understand the technology, then we can utilize this technology in any applications, and not only for our today talk this smart city, but also in any applications you can use. Okay, so in that way, if you know deep learning, I'm very much happy, and if not, I'm going to describe in a very simple way of understanding how the deep learning algorithms can be working for the prediction. You can see here now. See this deep learning basically it is derived from the machine learning algorithm, and of course this machine learning and deep learning all are from the basic AI framework. Okay, so these all technologies are from AI only. Okay, and in AI, in the artificial intelligence algorithm, so basically we can have a machine learning. Okay, we can call it as ML, and in the ML you can say it is one part of this ML is which is called DL, in the deep learning algorithm. Okay, so now you can see here the basic difference between the machine learning algorithm and deep learning algorithm. Okay, so now you can see here, this is the car. You can see this is the car. Okay, so now what I'm going to do here is that in terms of prediction problem, because we are talking about air quality prediction, so in terms of the prediction problem, I need some data, right, from the particular information. So here the input is, you can say imagine as the image, but in the layman you can see this is the information or this is the data. Okay, in this data, so what are the components which are available? Basically we call it as the feature. Okay, so in the car, so we have wheel, and we have a mirror. Okay, and also we have some other features like number plate, and what is the basic shape of this whole car. Okay, so these are all basically the features, we can say. Okay, so now what we have to do, suppose if you want to test the developed machine learning algorithm, whether with the same object or some different object. So basically we want to classify whether it is a car or not a car. So what we have to do, we have to identify the feature. So this is called basically the feature extraction. The whole process is called feature extraction. Then what here we have to do, after extracting the feature, we have to import this feature into the machine learning algorithm. Okay, so what this machine learning algorithm will do, they will collect all the feature from the data. Okay, then it will be making us the process of training. So once it is trained, then you can test this trained machine with any other information. Okay, then they will be automatically suggest whether this or that. Okay, so this is the basic fundamental about the machine learning concept, or we can say the machine learning algorithm. So here, the most challenging part in the machine learning algorithms are extraction of features, because this all extract the data or maybe the feature extraction from the input. So everything we have to extract based on the manual process, right? So all things are we have to do in manual. But if you coming into the deep learning framework, you no need to extract any information or any feature from the input image. What happen? The simple or the single deep learning network itself, it will extract the whole feature and it also classify in a single network, in a single network. So this is the basic advantage of the deep neural network, or we can say the deep learning algorithm. Okay, you can see, so here the most advantage is that this particular network, it never skip any feature from the image. But in manual process, what we can do, there is a chance some miss some features, right? So in that way we can get the overcome this kind of skipping of any informations from the input that has been avoided with the help of deep neural network. Then it can be going for any predictions or classification or anything else, so whatever we want to do. Okay, so I mean, this is the basic difference of machine learning and deep learning. And in most of the research problem, whatever the applications you are using, so that has been very much popular to implement the deep neural network, because the reason is this one: everything has been automated process. Okay, so how these deep neural networks are working? Basically, all the deep neural networks are working based on the brain inspired learning. What do you mean by brain inspired learning? Let me share with the a simple example. If say, for example, like I want to learn one definition from one textbooks. Okay, so what happens is that the level of understanding will be less. Suppose the same definition I am learning from 10 different textbooks. What happened? My level of understanding will be better than the previous, right? So this whole process is called brain inspired learning. So what we are doing here, we are inspiring, or we are learning from massive amount of data. Okay, massive amount of data. This is called brain inspired learning. So all the deep neural networks are working based on brain inspired learning, because they need huge amount of data, okay, to train the network. Then only we'll get the future predictions, or then only we'll get the correct predictions in the present. Okay, so for that, what we are doing, so basically for learning or collecting the more information, basically we are depending on the IoT. So the internet, from the IoT, we can collect the all informations or any related information, we will collect it. Okay, the only thing is that we have to be threshold from which year to which year we want to collect. Either it can be a air quality or anything, or the rain harvesting and other kind of thing, rainfall predictions. Okay, but when you're talking about the air quality management, so we have to threshold some timing. So based on the timing, how much amount of information we are getting, so those information we have to be built in the deep neural network, then automatically the network has been trained. Okay, now coming into the other deep learning introductory part, we know the basic difference between the machine learning and deep learning, and also we have learned how the deep neural networks are working. Okay, now in this particular deep learning technology, we need to depend some algorithm. Okay, so this is one of the very important and of course widely used deep learning algorithm, which is called convolutional neural network. So basically this convolutional network, it can be abbreviated as the CNN, we can say the convolutional neural network. Okay, now how these convolutional neural networks are working. So this whole convolutional network is working based on our convolutional, like our neural network concept. Okay, so how this neural network has been working. So basically in a simple neural network, so we have a input layer, and of course we have a hidden layer, then we'll have a output layer. Okay, so this is the whole process, and those who are familiar in the neural network will be very much familiar in this convolutional neural network. So once if we have the input data and it will pass into the hidden layer, then we'll get the output. Okay, so this hidden layer, it is happen on the back propagation process. So in the same way, if you look into the convolutional neural network, so the convolutional neural network is also consist of same, we have the input layer, and of course we have an output prediction. You can see the output layer, and in between what happen, this whole things we have a hidden layer. Okay, so in the hidden layer, what happens is that we have some couple of layers in the convolutional neural network. Say for example, in the hidden layer, we have to use the convolution process, which is, we can say, the convolutional layer, and also we have a polling layer. So the convolution process and polling process, we have to be performed in the hidden layer. From these two processes, we can automatically extract the feature from the given input. Okay, so you can see here in this whole input, we have lots of information. Say for example, I have been written in the output, we have dog inside the image, and we have cat, and we have boat, and we have a board, and much more. Okay, we have all these kind of informations are available in the image. So what happens is that this convolutional layer and polling layer, they can automatically extract the information from the image. Then finally what happens is that once the image feature has been extracted, then it will fit into the fully connected layer. So here the fully connected layer of the convolutional neural network, it can help for the classification. It can help for the classification, or maybe you can say that to differentiate from one to another. Okay, then finally we can use the softmax function, or we can say the softmax layer, for the prediction of the particular image, or prediction of the given input information. Okay, so in that way, these convolutional neural networks are working, and this is the whole architecture of the convolutional neural network. So why I have been explained very specific in this particular algorithm, because it is most widely used, deep learning algorithm, convolutional neural network. And of course, in all type of research problem, you can use the convolutional neural network. Okay, now coming into the automatic feature extraction. So basically, I have been explained in the hidden layer of the neural network, or in the hidden layer of the CNN. Basically, we have to perform two processes. One is convolution, and another one is like a polling. And another one is we have to use the polling. Okay, so what is mean by convolution? So we like generally we have been learned from our basic studies the convolutions, like what is convolution, and basically for performing convolutions we need two input, right? Okay, one is basically x of n, and another one is the h of n. That is basically we required. And here, while performing this convolution, what happened? We need the input. So this is some kind of information, and the another input basically we required. So this is basically, we can call it as the convolutional filter. And once these two inputs are performing with the help of the masking concept, then the input that will be getting based on the convolution process. Okay, so in the same way, you can apply the masking process, which is one by one from the input matrix, then you will get the whole convolved features. Okay, so from these two information, we will get automatically this particular output, or maybe the convolved output here. Okay, so here what happened, the dimensionality has been reduced from these two input. Then in the same way, if you repeatedly performed this operation for the entire the whole input information, so the feature has been extracted. In the same way, you can apply the polling process. What do you mean by polling process? So basically, if you consider this is an input information, so in this input information, suppose if you want to poll either in two process, one is the max polling, and we have the another is called average polling. Okay, there are two different types of polling. And if suppose if I am considering only 2x2 filter in this particular input image, only these two, what happens is that if I am applying the max polling operation, so the the layer or the architecture, it will find which one is the maximum pixel from this 2x2. You can see here, this is the maximum pixel. So that maximum pixel, it is automatically taking from the input. So this process will, the whole process will be repeated to the entire feature map. Then finally, we can calculate the max polling. So in the same way, so the polling process has been performed. Then finally, we'll get the whole feature from the information. Okay. So these are all like the whole the deep neural network fundamental. And if you know this fundamental, you will be very clear about this error prediction model. Otherwise, if you are very new to this particular deep learning framework, I hope my explanation will be understandable. I hope so. Okay, if you have any further queries in this, I will be very happy to answer it in the end of the sessions. You can make a note of it, so I'll be clearing everything if you have any queries. Okay, so from this understanding of you can say the whole deep neural network, now we'll coming into the our scope of the topic, which is called air quality prediction model. Okay, so in this air quality prediction model, so in a smart city life, how we can predict the air quality. Okay, so that is basic applications. So here I have been presented one of the very interesting architecture for predicting the air quality. Okay, you can see here in general in general cases, what happens is that, so this is the smart city like what we have been maybe living. Okay, so from this smart city or in the smart village, basically we have to be use lots of sensor devices, and of course for predicting the air quality. Okay, if say for example you can assume if I am going to predict the air quality maybe in 2019 to 2020, okay, in these 2 years, what happens is that, so the sensor that has been like collected the information from the respective years. So what happened, this data, like once it is collected, and this will be building into the deep learning model, our deep learning model. Okay, so here what happens is that for air quality prediction model, most of the research, I mean most of the this smart city related research, they are using the well known one of the deep neural network, which is called LSTM. Okay, I will explain what is LSTM, how it will be working in the further slides. So you will get more idea about the whole framework, how the air quality has been predicted. Okay, so once if you use the LSTM, then what happens is that this LSTM can give you the predicted data, okay, from the applied data. Okay, so once the data is predicted, what happens is that we have to be used in the process of labeling. Okay, so what do you mean by labeling? So in general, in all the neural network, basically we call it as the testing of the network. Okay, so, but here in the air quality prediction, we have to be label the unit. So how to label it? We need some reference, right? So once the data is predicted, we need some reference how the predicted data has been taken for the consideration, or how the decision has been made with the help of the predicted data. Okay, so that we basically we require the labeling. Okay, so the labeling can be done basically in AQI index. Okay, so what is meant by AQI index? AQI index is nothing but air quality index. Okay, so this air quality index, it's the predefined. Okay, so it is a predefined value. So generally we have an agency which is called like Environmental Production Agency. You can call it as EPA. So this EPA has been highlighted what will be the air quality index, from this index to the index, whether it is good or bad. I will be explaining in the next slide for more information, so how the APIs can be calculated. You can see here. So but for the understanding of this whole architecture of this air quality prediction, if you consider this labeling unit, basically we are using the AQI index. So the AQI index is the predefined value, so that we have been used in this whole architecture. And next is that we have to go for the decision, right? Once the labeling has been done, the labeled data has been done with the help of the AQI, then we have to go for the decision. I mean, in the prediction. Okay, so this prediction or the decision can be done according to the observed, and the predicted value. Okay, predicted values. Fine. So here observed value is like our data, and the predicted value is from the AQI. Then finally the decision has been made. Okay. So this is the the simple architecture of how the air quality has been predicted in a smart city life. This is one simple architecture how we can made it. Okay. And of course, this whole architecture I have been collected one of the mostly cited paper of Simsok, like the deep learning model for air quality prediction in smart city. It is one of the mostly cited paper. So, and of course, this conference is also very popular conference in terms of big data analytics. Okay, so this Koch has been proposed this architecture, and many architect, this architecture, a majority of the smart cities are utilizing this one. Okay, and of course this is commercialized also. Okay, and you can see here now I think you are very clear how this prediction, air quality prediction has been made. Okay, but being an engineer, we should understand from the basics. Okay, then only we can able to propose or any new air quality prediction model, or we can able to perform whatever the model which is currently available, or how the existing model which is available. Okay, so in that way my further explanations will be will help you to make understand this whole fundamental about the air quality prediction model. Okay, so now if you going into the AQI, and of course if you are very new, this particular slide will help you how in a smart city life, how the air pollution and of course the AQI, the quality has been predicted. So the air quality index value based on the AQI values. Okay, so the Environmental Protection Agency EPA has been defined this value. Okay, if it is 0 to 50, and what happens is that the level of health concern is good. Okay, and it is generally they will use the color for differentiating the quality of air. Generally it is good, they will mention in the green color. And of course the AQI value is 51 to 100. It is basically it is moderate. Okay, so they'll be highlighting the color yellow. And if it is 101 to 150, and it is unhealthy for the sensitive groups. But even though we can survey, but it is very dangerous. So it is mentioned in the orange color. Okay, so the rest of the AQI values 151 to 200 is unhealthy, 201 to 300 very unhealthy, and 301 to 500 is a hazardous. And the respective color is also mentioning based on the EPA and Environmental Protection Agency. Okay, so here what happens is that if you want to predict any air quality management, so this AQI index value, which is very much helpful for the labeling the predicted value. Okay, so this is the defined value, so which has been used by all the researcher for predicting the values. Okay, and now we are very clear from this particular architecture how what is AQI index, right? But now to move further, to make understand more about this particular Lstm network. Okay, so we should learn about the mathematical background of this whole Lstm network. Okay, now being an data engineer, so I like to share some more very basic fundamental about the Lstm. And if you know about the information about Lstm, it will be very good. If not, and maybe my explanation will help you to make more understand about the Lstm. I'm just going to take very less time. But even though then once if you understand the Lstm, then the whole framework will be like more easier to understand from the participant perspective. Okay, now coming into this particular perspective, so basically this LSTM, which is called like it is one of the special kind of RNN, we can say. Okay, special kind of RNN. What do you mean by RNN? Again, it is coming from the neural network perspective. RNN is nothing but recurrent neural network. Okay, you can say recurrent neural network also. The pronouns is same, like almost both are same. Here, so in this LSTM is the family of RNN, I mean in the recurrent neural network. And this particular LSTM, the advantage of this LSTM in the in the machine learning framework is that it is overcome the vanishing the gradient. Overcome vanishing the gradient. I will explaining you what is mean by overcoming the vanishing the gradient in my further explanation. Because if you like overcome the gradient, what happens is vanishing gradient, and your dimensionality will be reduced, and of course the processing time will be better. I mean in terms of the computational perspective. Okay, so now in this case, if you coming into the I mean in the LSTM, what is basically this LSTM? How this LSTM is working to predict the future data? Okay, so that is very much important. So basically, this RNN, the basic fundamental of RNN is nothing but it is working, or we can training, or we can call it as learning. So this learning basically it is through the back propagation algorithm. Back propagation algorithm. So all these RNNs are working based on the back propagation algorithm. But now it is coming into the architectural perspective. This RNN, I mean the recurrent neural network. So this RNN basically consists of, we can say, I think I have been deciding my camera because I'm just using the writing pad. So if you see here in the architectural framework, if say in the LSTM, or we can say in the RNN, basically in the RNN, we have an input layer. So generally this input layer, which is mentioned in X, and next we have a H, which is called hidden layer. So in this hidden layer, from we'll get the output, which is called Y. Okay. So here what happens is that in the X, or we can say in terms of hidden layer, we will get the whole output. So here the input will passing into the hidden layer, and from the hidden it will passing into the output layer. So here what happens is that the hidden layer, or maybe in the middle layer, it will be processed based on the process of back propagation. This is called basically back propagation. Okay. Now, as I told you, in the air quality management, how the future has been predicted. Okay. Now, if you coming into that particular perspective, you say here, in the past value, we can say in the whole perspective, say for example, we have a X, and of course we have a H, and of course the output is Y. Okay, so all these layers are explaining in generally with the help of we can say the time series data, right? So if I'm representing this is X t minus 1, I mean it's the past data, and of course this is H of t minus 1, can say, and this is Y of t minus 1. Okay, so here in this whole, I mean the input and the output, and in between we have a hidden layer. Okay, so in a neural network perspective, we have to assign the weight from the input to the hidden layer if it is represented Wx, and from hidden to output, which is called Wy, we can say. Okay, So here, what happens is that from that we will get the whole output from the past. Okay. Now, if you going into for the present value, okay. So the I mean in the present value. So what will be the present value? So this present value basically we have the same way in the xt we have xt, and also we have ht, and also we have the output value yt. Okay, so here in the same way the input and output of the current value also that we have been measured with the help of weight value. This is again wx and it is wy. Okay, so this value the will pass into the whole general weight wn. In the same way, if you know the present and past, then what happened that recurrent neural network will predict the future value. I mean, if say for example x of t plus 1, we can say this is h of t plus 1 and y of t plus 1. Okay, so this whole value we can able to find it with the help of this recurrent neural network. So finally this is also will get wn, I mean the weight, and the whole weight will be calculated with the help of the like recurrent neural network. So here what happens is that if you understand this whole architecture of this recurrent neural network, so this particular recurrent neural network, so basically it will extract the the future value from the past and the present values. Okay, so in the same recurrent neural network concept, this LSTM is working. I mean, so this LSTM can basically use the RNN architecture, then it will be predicting the future value. Okay, so now to make more understanding about the this LSTM for the audience, so I am basically explaining the architecture of the LSTM, then you will be getting the clear idea about this one. So here what happens is that in the RNN network, so in any form of neural network, basically we have to use the activation function in the neural network concept, right? So here what happens is that, so this RNN, I mean the recurrent neural network, basically it will use the activation function of tan h. Okay, so this activation function basically we have to use for the past value as well as the present value as well as the future value Okay, so if you see here this tan h is the activation function, you can see here, and this is the hidden layer h, and of course the corresponding input is basically x of t minus 1. Okay, x of t minus 1. Okay, just a minute. So in the same way, you can use the same method for the other output layer, which is called like this is x of t, and this is also we can give it to the other. It is like x of t plus 1. Okay, then finally we'll get the output. So here this whole like the activation function basically we used for this RNN network, I mean the recurrent neural network. This is t minus 1. Sorry. So this is t x of t minus 1. Okay, so now in this RNN we can learn that like how we can get the future values. In the same concept, in the RNN concept, what happens is that the LSTM network is using like you can see here this particular LSTM network basically it is working like a recurrent neural network, but except in addition to that cell. Okay, so now what happened, just I'm taking 2 minutes to explain this LSTM, then I will continue into that, because once if you have the fundamentals of this, then I hope you will be understanding the whole prediction process. Okay, so here in the LSTM, how the LSTM is working. So basically this LSTM, that will be consider the RNN. In addition to that, the cell structure. If say for example, the LSTM network, suppose if I'm considering the 3 structure, say 1, 2 and the 3, total 3 structure. Okay, if say for example, this, as we know from the RNN, so there are 3 is there. So this is, we can say, if say for example, this is h of t minus 2, and this is, we can say, h of t plus 1, and if it is, this is h of t, and finally they will get the future h of t plus 1. In the same way, if you are getting the LSTM, basically it will consist also the cell structure. So this each in LSTM network, each and every block we call it as cell structure. Cell structure. So in this cell structure, in the same way, we can represent mathematically C of t minus 2, and this is C of t plus 1, and we can say this is Ct, and also this is Ct plus 1. Okay, so this all LSTM cell, in each and every LSTM cell basically consists of 5 following parameters. 5 following parameters. So what are those parameters? One is that like a simple, it is like a simple RNN cell, and next we have the cell state. Okay, so here the cell state, basically it is represent long-term memory. Then also the LSTM, which also consists of forgot gate. Then number 4, the input gate. Then finally we have a output gate. So in a sample LSTM network, or we can say the single LSTM network, which consists of all these 5 parameters. So with the help of whole, all these 5 parameters, we can extract the future values. Right. So next, being for more understanding, we should clear about how this this whole value that the future value that has been predicted with the help of LSTM. Okay, so here for the understanding purpose of the audience, so I have been explained the only the background, the background of the LSTM. Okay, and now if you concentrating more on this LSTM network, then what happens is that automatically the C of t plus 1 and the H of t plus 1 that has been performed. Then the final predictions, generally it will be the combination of these two. Then the Y, the output, will have to take the dot product of C of t plus 1 and the H of t plus 1. So in the same way, we can getting the output value, the future value. Okay, so from this value only, I think like we are getting from the predicted data in the architecture. Okay, once the predicted data has been obtained from the LSTM, then what happened? This value we are going into the comparing with this AQI value, how much value we are getting. Then automatically the level of health concern that will be predicted with the help of the decision unit, whether suppose today, maybe tomorrow and day after tomorrow, what will be the air quality prediction? If the air quality prediction is been sustainable way, then no need to worry. If not, then what happens is that as the government or maybe the stakeholder or maybe each and every human being, so we have to take some precautions about the future air, air quality. Okay, so in that way, this whole model can help you, to make your life in a more smarter way. Okay, more smarter way. So this is like a simple, applications and the, technological based explanation to the participants. And once you understand this whole concept, and I'm sure you can able to do a lot of research in this air quality prediction model. Okay, so how this model can be working, so I can suggest you the audience, please, you can refer this whole paper. Okay, you will get even more understanding about than my presentations. So my objective is that some applications may be presented to the participants, in a research framework. Okay, that is my whole objective. Okay, so now this particular model is already available in the market. I mean, this particular model is has been commercialized. Okay, so now to make understand this whole air prediction model, as a researcher, as the engineers, you can able to do lots of research or lot of modification in this. Okay, so that I want to basically suggest you, you can do some kind of future work from my lecture. Then you can able to propose some new air quality prediction model, maybe better than this, who knows. Okay, that is based on your own research outcome. Okay, and basically I can suggest you, if you want to work with this air quality project or this air quality model predictions, you can use this data set. Basically we need data to process this, right? The City Pulse EU F7 project. So this is the data set, so which is freely available to you. Okay, so this data set is you can directly collect from the internet. So this data set can give you many informations, okay, to use our deep neural network. So they will be giving more information about the pollution and weather forecasting and road traffic. Maybe the other application you can see, the smart parking, how that has been helped you. So like this particular data set, basically it is very much popular, those who are working in the smart city, research works. So you can get lots of data set, a lot of information from this data set. So if you have been interested, you can download the data, and of course you can use our either the deep neural network, and of course any other like the deep neural network that I am going to be suggest in the further slides. Okay, so because this model is basically it is available, right? So if you are writing and if you are performing, you will not get any novelty, right? So basically if you want to publish something, you need some novelty. That is basic criteria for that, right? So here in this way, so once if you predicted the model, and basically the performance analysis is one of the most challenging job, or one of the important tasks of the researchers like us, right? So here what happens is that in any air quality prediction, the AQI that has been suggested, there are two available performance metrics. One is that the first one we can say that this is called mean absolute error. So this mean absolute error, and of course the other one is that root mean square error. So these two performance metrics basically help you to perform your obtained predictions, whether how the performance you have been obtained, how much percentage the predictions will be correct. Okay, so in that way you can use mean absolute error. So it is basically defined as 1 by n into the summation I equal to 1 to n, and this is alpha I minus alpha I dash. Okay, so in this expression you can say The alpha is nothing but the observed data, and alpha I dash, which is basically, we can call it as the predicted data. Okay, so if you perform this analysis, you will get the mean absolute error, and here the n is nothing but the number of prediction. N is the number of prediction. Okay, so if you use this particular performance metrics, of course you can find the performance, how much you can able to do that. The same way, if you use the root mean squared error, so this is also the simple mathematics, as you can know. It is square root of 1 by n and summation I equal to 1 to n. In the same way, like alpha I minus alpha I dash, like we can say that it is the whole square. Okay, if you use these two particular performance metrics, and you will get you can able to analyze whether the obtained performance metrics is well or not. Okay, so this is like the performance analysis. And of course, if you want to perform this whole air prediction model, and of course you have to be use this common Aqi index value, and also it suggests some other values. So the combination of the ozone and nitrogen dioxide. So in the air quality, how much percentage of ozone and nitrogen dioxide is there. So based on that, the Aqi also suggests the values. So if you can use these two values for the model training of any deep neural network, then you can easily predict the values. Okay, so like this is what my plan of the today talk. So how the deep neural network can be utilized for the air quality prediction in the smart city applications. And also I want to give you a very light note on that other application, which is called traffic monitoring in the smart city. You can see here, this is one of the most popular and recently published traffic monitoring model in the smart city using deep learning. And you can see here, they have been used both like even in the convolutional neural network as well as the LSTM. Okay, and the combination of these two, they are using for extracting the features and model. Then finally they have been used the fusion concept to predict the monitoring. Okay, so the idea is that the technology, whatever the technology we are discussing, so it is always using for any type of smart city applications. Like you can see here the other things we can learn from our own, because this paper is publicly available. I'll request to read the paper if you want to do something in the traffic monitoring case. Okay, so the idea is that I've been explaining the air quality, but also as a researcher, you can work in other smart city applications, like simple. And now I'm almost coming to end of the today talk. So being a researcher, I have been explaining you how the existing models are working in smart city application, but also as a researcher, I want to suggest you, so what kind of modifications you can able to do in these kind of applications. First is that basically whenever we are using any deep neural network or any deep learning algorithm, the researcher, we have to face a lot of challenges, right? So here what happens is that if you use the deep learning, we have to face a lot of challenges. One is the data. Okay, because of course the data collection is very, very important, right? So this is the most challenging job, right? So once the data is ready, then what happens is that we have to go for the model. So which model we have to use? If say for example, if you are using deep learning, okay, if say which model we have to use, whether it is go for CNN or LSTM. Okay, so the selection of model itself, it is one of the most challenging job, right? Say for example, if you coming to the CNN, we have other pre-trained networks. So many pre-trained networks are available, like say AlexNet, okay, GoogleNet, so many pre-trained networks are available. So which network or which model I can select for my research? So that is also one of the challenging job. Okay, And finally, interpretation of result, we need some reference. So here in air quality management, we have the Aqi Index value. In such a way, if you want to do any kind of application, so to interpret the result, so you have to be dependent with some kind of interpretation. You need some reference. Okay, so these are all the three challenges for the deep neural network researcher. And apart from this, you need the large computational facility. Okay, computational facility is also one of the very important parameter in the deep learning research. You need the workstation with the GPU, graphics card, then only your system, the whole architecture, the prediction model will be working very fast. Okay, so these are all the basic challenge. So before getting into the research, so you just over like address all those issues, then you can start your own research. Okay, so if you like instead of the CNN, I can say you so here in the traffic monitoring, they have been used the simple convolutional neural network, CNN. So what you can do for modifying this particular research, what you can do, you can able to do any like try any other pre-trained network, AlexNet, GoogleNet, VGG, Inception, ResNet, SkewsNet. Then what happens is that so maybe if you use any other pre-trained network instead of the CNN, maybe the output will be better. Who knows? So we have to perform it. Okay, so in that way you can modify this particular research. And of course, apart from this changing of this pre-trained network, you can also use some kind of novel training methodology in the network. Okay, in both any air quality management, or it may be a traffic monitoring system or anything. So you can use transfer learning, you can use extreme learning, or you can use the optimized learning, okay, for to train the data. So in that way also you can able to propose some novel architecture, okay, in this field. And when you are coming into the optimization, so the transfer learning and extreme learning, and the optimization basically it is performed well than the others too. The reason is that in any deep neural network, selection of hyperparameter is one of the challenging job. So the selection of hyperparameter that has been addressed with the help of the optimization process. Okay, so like I'm not taking much time, just you can learn it what is optimization and other things, and you can use the any meta heuristic optimization algorithm for selection of hyperparameter of the deep neural network. So you can use any evolutionary algorithm, or you can use physics based algorithm, or you can use some swarm based algorithm. Like I think you may have genetic algorithm, differential evolution, gravitational search algorithm, whale optimization, cat worm swarm. So these are all PSO. So any type of optimization algorithm that we can use as a novel process to train the network. Okay, and also in the research we have a huge number of swarm based optimization algorithm which is also availability. Okay, so you can choose any algorithm. So many evolutionary algorithms are available. So if you make the try with one by one, and of course each and every testing of each and every algorithm is one kind of research outcome. Okay, that point maybe you learn from my presentations. So how these like idea may be utilized in the smart city applications. Okay, so in the conclusions, I of course if you want to implement any smart life automation in the smart city, of course internet is required. So we always depends on the IoT platform to implement all the things in the smart city. And of course in the smart city you can able to do lots of research based on your innovations in smart cities. Say for example this air quality predictions, and smart way of clearing the dustbin, and the smart monitoring system and parking systems, everything you can do that. And if you want to use this deep learning in all these applications, basically I can suggest you to use this particular idea like hyperparameter selection in the deep neural network. So in that way you will get the optimum result in the like smart city applications. Yeah. So as a conclusion note, so being an ITN, so we are always looking the collaborations to work with the the faculty like you or with any other students. So basically from this presentations, if you have a MTech degree, suppose if you want to do any PhD in a central funding institutes like NIT, so we are always welcoming you. So basically this NIT culture is offering PhD fellowships with, if you have a good academic background with BTech and MTech. So basically this institute is offering a PhD program in two mode. One is Group A and another one is Group B. So Group A, basically it is fully funded by the government of India with the stipend. Okay, so for that you need the GATE score. Okay, GATE score is mandatory for getting the stipend from the government. And if you don't have GATE, you can apply for the Group B category. So in the Group B category also we have two mode. One is Group B full time and another one is, this is the part time. So Group B full time, you no need of any GATE. Okay, no GATE, but also the government will not provide any funding, but it is a self supported. Okay, and in the part time also does not require any GATE. So you can work anywhere from the country, but the first semester you have to be present in the campus for doing the coursework. And primarily you have been as a engineering institutions teacher or maybe working in any other research institutions. Okay, so you can, once if you fulfill the institute criteria, then you will be awarding the PhD degree under the part-time. So apart from this, we have providing so many internship opportunity for the engineering students and also the engineering faculty, those who are working in the other institutions. Okay, so if you want to do want any help from my side, so I'm feel free to help to in any kind of help, so which can be possible from my side. So you can write email to me. So I will be almost available. So within 24 hours you will get reply from my end. And if you want to take more help or money or anything, or in my contact number, anything which is always available in my institute website, you can log into nitsac.in. So all information you will get it. And of course, if you want to contact, you can write a mail or you can call me. So I'm always available to help you in any time, in all time. Okay, so with this I am concluding this lecture. I think I'm almost in on time. The remaining time I can give you for question and answer. If you have any queries or maybe from the presentations, maybe from out of the presentation, so I will be very much happy to answer if some queries if you have. Please.
You may ask now. You can post your question in chat box or else raise your hand. We will unmute you.
Hello.
Yeah,
Hello,
please.
Sir, you have just explained about the air quality modeling for city level, but can we use this technique for industry as well? Because see, industry, if you take example of any industry, they can through the chimney, lot of smoke is emitted. So can we use this technology at the industry itself? So that the air quality or the what you can say can be monitored at source only. Can we use such a technology, sir?
Yes, madam. You can absolutely use for this. So without any doubt. But only thing is that this model is you have to be customized for the smart city or maybe the industry. It is based on the data, what data you have been imported. Okay, so as a technologist like us, we can propose only the model, right? But in the testing side, when you're going for any industry or maybe the smart home or maybe the smart village or smart city, so the only thing is that the data will vary. Okay. So other than this, the architecture will be same. You can free to use anywhere for any applications.
Okay, sir. Thank you, sir. One more question from my side, sir. You have any postdoctoral program at your institute?
Madam, as of now, the government of India will not support any postdoctoral program for NIT. It will be applicable only for the IITs.
Okay.
IIT only providing the postdoc.
Okay. Because I am from civil engineering background, sir.
Okay, madam. Thank you.
Yes.
Thank you.
So
Yeah,
I
if
want
you
to.
have interested for doing postdoc, so better you can reach to any IIT professors, and those they are like IIT in government they are giving the the permission to give postdoc only in IIT level.
Okay, sir. Okay, thank you so much, sir.
Yeah, thank you. Any more questions?
I think there is no more queries from participant side, sir.
Okay, thank you. So everyone is asking feedback link. Okay.
So there is one more queries in a chat. Apart from prediction, any method is available to monitor the air quality?
Sorry, can you repeat the question?
Apart from prediction, any method is available to monitor the air quality?
Method?
Yeah.
Yeah. So many methods are available. Like if you are talking about this, artificial intelligence, so we are using this deep learning. I mean, if you have a past data, then you can predict the future. Then of course, deep neural networks we have to use. But out of like other than this deep neural network, you can go with like the what data we have presently available. Okay, so if you ask some methodology, you can go with any the classification methodology of machine learning, say for example k-means clustering, or you can go with SVM itself, support vector machine, navy based classifier. So these methodologies can also help you to predict the like the values, like without any like the the past values. That is also possible. You can use that.
Thank you, sir. Thank you.
So thank you, sir. Sir, let me wind up the session, sir.
Yeah, please.
Talent wins games, but teamwork and intelligence win championship. In this way, now I'd like to thank our today's resource person, Dr. R Murugan, Assistant Professor, Department of Electronics and Communication Engineering, National Institute of Technology, Silchar, SM, for providing the wonderful session on the topic of application of IoT in a smart city, a research perspective. On behalf of organizing team and Governor College of Engineering and Technology, we once again thank you so much, sir.
Thank you.
Thank you, sir. And participants, the day 4 session 2 attendance and the feedback link was posted in the chat box. Kindly check it, and it will be open up to 30 minutes only. Thank you all. And that day 4 session 3 will start at 2:30 p.m. So kindly join at shop time. Thank you all.
Yeah, thank you very much. I'm leaving the meeting. Thank you. Bye bye.
Thank you, sir.